Hi, I'm really excited to be here with you today to talk about the psychology of chaos engineering. I'm Julie Gunderson, a DevOps advocate at PagerDuty, and I pinged some folks on Twitter and asked, what is chaos engineering? And I got so many different responses from folks. Some testing your people, breaking production for fun. Well, let's talk about chaos engineering. So chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. And where it came from, there's a lot of differences of opinion here. When people first became aware of chaos engineering, it was from Netflix. They had this tool called Chaos Monkey, and the intent of Chaos Monkey was that it shut off services in production, which really created this need for defensive coding, because in reality, systems are turbulent. It's not if, it's when. And now that's more into more than just shutting things off, and it's really about experimenting. It's not about the tools. The tools are really just a means to the end, and it's really about the experiment. So take a look at what Sidney Dekker says about resilience engineering. Resilience engineering is about identifying and then enhancing the positive capabilities of people and organizations that allow them to adapt effectively and safely under varying circumstances. So when we talk about what chaos engineering is, people often say, isn't all of engineering chaotic? And some people, they have no idea what chaos engineering is. And chaos engineering really isn't about breaking things. It's not about trying to test our people, and it's not about trying to figure out how we can make things fail. It's not about engineering being chaotic or processes being unpredictable. There's a lot of work that we do that's unfortunately named, and chaos engineering is one of those. So we don't need to take chaos literally. It's about experimentation. We're creating a hypothesis. We're saying that we believe that if a certain thing happens, that this is what's going to happen to our system. We believe our system is reliable. And we don't want to go in and just turn things off and see how we can break things. We have to have that hypothesis, because if you don't have a hypothesis, then how do you know if you were right? Or how do you know what you've learned? And so we talk about efficient and effective organizations being learning organizations, and chaos engineering is a very effective tool for learning more. At PagerDuty, we say that incidents are gifts. As humans, we can't talk to our systems directly. We have to communicate through a proxy. So an incident is a way for our system to tell us something. And what's better is if we don't have to wait for an incident, if there are ways we can encourage our systems to tell us about themselves in their ways so that we can learn more. And we do this by creating that hypothesis and then testing it. And so when we talk about chaos engineering experiments, some people say that you have to run your experiments in production. And running in prod is preferred, but it's not required. Now, there's no testing like testing in production, because no matter how good you think staging is not production. Charity Majors, she said that nines don't matter if your users aren't happy. And the reason that I bring this up is to remember that we live in a world of scale. So we understand that chasing 100% reliability is a fool's errand. And we want to say that the minimum acceptable uptime, is it 3 nines or 4 nines, but we still have to remember that there's a human on the other end of that 0.001, somebody that's still trying to do something. And we want to think about the impact to them. And so it doesn't mean that we shouldn't experiment and test in production. It means that we need to be equipped. Because I'm going to tell you that if you say you aren't running experiments in production, you actually probably are. They're just really crappy experiments and you don't know what they are. So the better control and the better understanding we can have, the more resilient our systems and our teams can become. And so we want to think about observability when we're doing experiments. We have to be able to understand the impact of what we're doing. We have to understand when we need to pull back on the experiment. Maybe we hit a gate that says this is too much because we have a hypothesis, but what happens when we prove our hypothesis false? So our hypothesis might be that if we shut down a particular system, our circuit breaker is going to kick in and people are still going to be able to watch their movie. But what if they can't watch their movie? We have to be able to back out of that. We have to have an understanding of our system and what that user experience is like. We also want to understand the blast radius, and canaries are a great technique when running chaos experiments. And so you want to think about the blast radius. So you don't have to perform your chaos engineering against all of production, just perform against 5% of production. You also want to document the expected behavior. You want to think about what the potential or possible failures are. You want to pick a time when the stakes are lower with minimal impact. So you want to think about your SLOs here. You don't want to pick a time where you could breach those SLOs or where they're close to being breached. At PagerDuty, we run Failure Fridays to uncover implementation issues that reduce our resiliency and to proactively discover deficiencies and avoid these discrepancies becoming the root cause of a future outage. We also find that this builds a strong team culture by coming together as a team once a week to share knowledge so ops can learn how development teams debug production issues in their systems and devs gain a better understanding of how their software is deployed. It's also a nice perk to train new hires on how to handle incidents at 11 a.m. on a Friday versus 3 a.m. on a Saturday. And it reminds us that failure will happen, and failure is no longer considered a freak occurrence that can be ignored and explained away. And so injecting failure and continuously improving our infrastructure has not only helped us deliver better software, but also to build internal trust and empathy. And that's when I go back to chaos engineering is not about testing your people. It's about building that internal trust and empathy. We're stress testing our systems and our processes to help us understand how to improve our operations. And you don't want to forget about the people. We understand, and it's been proven that following chaos engineering techniques will let us understand our systems better, and it'll cause us to build more reliable and stable systems that help us build more resiliency into our organizations, into our things. And that's great and good for all the computers, but the people. So that's the thing. You've all experienced it. You just don't know it. And most people seem to be okay with Netflix. When you see this, it means that they know their system. I'm not going to miss out on my shows, but then you have to think about, what about when your bank does it? It's quite a bit different from when you get the "we can't play this" title right now. You might be trying to pay a bill or transfer money or do something critical. So does that mean that financial institutions and other industries like that shouldn't practice chaos engineering? Absolutely not. It's actually absolutely necessary for them. But you have to understand that when practicing these techniques, you have to have that hypothesis, and that you're teaching your organization how to learn and fail gracefully, and how to understand retries, and how to understand these things. So this is when you can start small. At PagerDuty, we have some systems we don't run Failure Fridays on production in, which is part of the hypothesis. I don't think the system is as resilient. One of my favorite quotes is from Bruce Wong, and he says that saying you're getting your systems ready for chaos engineering is like saying you're getting in shape to go to the gym. You can buy gym shoes and shirts and shorts, but at the end of the day, you just have to go to the gym. You don't get in shape first. And the same thing applies to chaos engineering. You need to design your experiments and have your hypothesis. You also need to think about the organizational culture, but at some point you need to just jump right in, whether that's in staging or in production. Now, management can get a little bit nervous, and I talked about unfortunate naming for things, and C-suite doesn't always like the word chaos. They don't love the word failure. So think about what you're going to call it. Think about using words like education, experiments, and learning, because the words that we have a lot of weight that they carry. And we want to remember that there's a mental and philosophical shift that needs to happen to embrace and learn from these types of techniques. And so you want to also prepare your people. At PagerDuty, before a Failure Friday begins, it's important that we make an agenda of all the failures we wish to introduce, and we schedule a 1-hour meeting, and we work on as many issues as we can. We also keep our PagerDuty alerts turned on to confirm that we're receiving alerts and see how quickly they arrive in relation to the failure that's introduced. And so you can see that some people feel excitement over chaos engineering. Cody felt excitement over a new error that hadn't occurred before. It's a really great opportunity to bring in junior developers and give them more freedom to do some things, because they think of things in ways that we don't always think of things. They have new ways of looking at things. They might ask different types of questions. And don't forget about safety. I mentioned this with blast radius and minimizing the impact. You want to go into your chaos engineering experiments with your eyes wide open. So you want to understand what your key metrics are. So like at Netflix, a key metric is stream starts per second. You want to think about when can you back out of these chaos engineering experiments. And then I just want to leave you with a few key concepts here. You want to build that hypothesis and very real world events. Run your experiments in production. automate experiments to run continuously, and minimize that blast radius. And here are some great resources to take a look at for when you're ready to run chaos engineering in your organization. And with that, I just want to say thank you for having me today, and I hope you're enjoying the conference.